Hello everybody, in this video we're going to be talking about more transformations of quadratics, but in this video we're going to be focusing on transformations that involve c. c is going to change the y-intercept. It will shift the graph up or down. And the reason it does that is because if you're doing the y-intercept, then you're going to be plugging in 0 for this, and the only thing you'll have is that letter c, because c does not care what you plug in for your variable. The reason c doesn't care is because c is the constant. c will be the same no matter what you plug in for x. You're going to add or subtract whatever that random number is at the end. Let's go ahead and graph these two things really quickly. This is the parent function, and then we're going to do a plus 3 on top of the parent function. In my calculator, I'm going to put x squared plus 3, and then look at the table. And we should get the familiar shape that we're used to seeing. For the second one, we'll do x squared minus 4. Look at the table. And this is still a familiar shape. It's just shifted down. 0, negative 4. 1, negative 3. Negative 1, negative 3. And there's our x-intercept. So in general, we could say that the graph is always going to shift c units up or down. If c is a positive number, it'll go up. If c is a negative number, it'll go down. Starting with the first thing number 1 wants us to label. Is it a maximum or a minimum? Since this graph is opening upwards, it's a minimum. Since it's opening upwards, a is positive. And if we look at just how these numbers are changing, if we look at the vertex, and if we go one number to the right, we are only going one number up. If we go 2 numbers to the right of the vertex, we're going 1, 2, 3, 4 up. So this is following the same pattern as the parent function. Since it's following the same pattern, a has to be 1. The reason is this graph is not any skinnier or wider than the parent function would have been. It's only shifted to the left and down. We're going to identify c. c, if you remember, we just wrote it. c changes the y-intercept. c is not the only thing that changes this. This is not c. c is not just that shift down of 5. c is this thing. If you plug in the number 0, 0 for x, you should get c as your y. So c is equal to the y-intercept, which is negative 1. Then in this final question, if the entire parabola shifted 3 units down, then this c would go 1, 2, 3 spaces to right here, which is at negative 4. Identify the maximum or the minimum. Okay, this one's a maximum. Is a positive or negative? It's going to be negative because upside down. And if we look one space over, we're only down by 1. If we look 2 spaces to the right of the vertex, we are 1, 2, 3, 4 spaces down. So this is following the same scale as the parent function, so that means a is just negative 1. All that happened to this graph is it flipped over, but it's not any skinnier or wider than the parent. Identify the c. The vertex is shifted 2 units up, but the vertex is not the same thing as the c, because the c is the y-intercept. The c is going to be -2. If the parabola was shifted 4 units up, then C would be 4 more than that -2, so then C would be equal to 2. And that would just take the graph and move every little space 4 numbers up. Try this example on your own, and then after this, it's just your practice for the day. I'm going to show you the answer now. There's the answer to that example. Now start working on the parameter changes practice. Both pages of it.